Nearly 80% of the buildings we'll use in 2045 have already been built. Many were built long before energy efficiency was even an idea. Yet they hold the key to Scotland's net zero carbon future. Retrofitting these buildings isn't optional, it's essential. Essential to create the sustainable places we need in the future. Essential to make them warmer, healthier and more comfortable for residents. Our priorities are clear. Reduce energy demand to cut consumption and emissions. Enhance building performance for comfort, health and well-being. Decarbonise heating and energy systems. And reimagine and reuse our buildings, preserving heritage and avoiding waste. Best is Scotland's National Innovation Centre for the Built Environment. Our mission is simple, it's to accelerate the built environment's just transition to net zero carbon emissions. We do this by collaborating with partners to create buildings that are stronger, smarter and more sustainable. And we lead by example, starting with our own innovation campus here. Funded through Phase 1 of Scotland's Public Sector Heat Decarbonisation Fund, Edinburgh Napier University, our host institution, secured £1.2 million of funding from SALIX on behalf of the Scottish Government. Designed to meet Passive House's EnerPHit standards for retrofit buildings and achieve net zero emissions, this Phase 1 has transformed the National Retrofit Centre.
Globally, we don't have the carbon budget to start again. We can't knock every building down that's inefficient and build a new super energy efficient building. There's certain assets out there that we wouldn't want to do that with as well. Retrofit's incredibly important towards our overall decarbonisation mission.
We want to, resolve the problems that the existing buildings have today, so moisture build-up, cost of heating it, but we also want to decarbonise the building. So that's why at the core, that's why retrofit is so important.
One of the aspects of this project that we're most excited about is the fact that it's retrofit. It's great to do new build projects where we can deliver homegrown mass timber to displace more carbon intensive materials. But even better when we can take a building that already exists, but in the case of this building and then so many buildings in the landscape where their performance is so poor, they weren't designed to perform well. The structure of the building is still fit for purpose. The external fabric is not.
The difference between retrofit and a demolition and rebuild project is really our approach from the outset. A lot of it's about learning as much as you can about the existing building, doing gap analysis and research to understand the building, and working out what the potential issues are as far as in advance as you can.
What makes this project so exciting is that we are implementing deep retrofit measures overall, but we are implementing best practice strategies. So we did a very deep research and what's the best combination of measures that should be installed for this specific case. And we are not only taking into account the operational energy target or strategies, we're also taking into account embodied carbon measures, and we're also going to test how those technologies perform.
Still plant room 2. Okay, yeah, that's fine. Right, that's right.
So that justifies, so that confirms that our
I think the biggest challenge on this project is the biggest challenge that all of our stakeholders within public sector face on retrofit projects, is that you've got the unknown.
There was little to no information about the existing building, which meant that it was challenging to assess quite what could be retained, if anything. So we relied a lot on survey and information, measured surveys, this sort of thing. There were structural investigations carried out with a structural engineer, which were really beneficial, but there was only so much we could know.
I think the biggest challenges were the kind of new constructions or panels that tied in with the existing building fabric. Obviously it's easier in the kind of passive house buildings like schools and that when everything's new, you've got control over everything. But on the interfaces where the new was meeting the existing, that's where all the kind of challenges came from.
Today, members of the team from BEST and the design team have been working with Ecosystems to manufacture one of the CLT panels that will go into the project.
The panelised system uses our homegrown CLT as the core ingredient. That CLT works really hard for the project, so it provides the structural panel, which means that we only need to take minimal support from the existing armature, the existing steel structure of the building. We can span between ground and mid-level and top. So it performs really well from a structural technical perspective. But of course, we're using the internal finish of the CLT as the finished building. So then with that, we get that uplift in value and performance, because we get that fantastic biogenic benefit from that finished timber surface. So it's very timber rich. It makes that amazing space to train, to teach, to whatever the spaces might end up being.
So today's kind of been a long time coming. We had originally by this point intended that we would have done 3 crane lifts staggered 2 weekly. The first of these we were slightly delayed because of the workability of the material and learning on site. We were using new processes. We were upskilling a lot of people on the job when we were learning. That took its toll in terms of programme. The advantage, the way in which this system is being designed and the fact that it's being delivered off-site allows for site progress to continue internally on the building. So the strip out and fit out of the MEP packages is independent of the cladding system. So we actually, albeit we have notionally lost time on programme, we haven't lost any time in terms of our contractual programme. On a standard job, if we were to lose that time in terms of building on site and not off site, that could have run into tens of thousands of prelim costs, but we've been able to absorb that because we're able to run 2 activity streams simultaneously on the job.
After all the work on the fabric, a big part of it is the services, which encompass the heating and ventilation. So it's a great deal on the heating was to get off gas. It was always going to be a heat pump, but we were really excited when we proposed a new solution, which is a solar thermal PV hybrid heat pump, which hasn't been done on a commercial building in Scotland before. And the client was like, "Oh, I think we'll go for that." And I was like, "This is great, because you don't often get to push the boundaries a bit and, kind of play around with new ideas." So heating was really a highlight for us. Ventilation, an old building had pretty terrible ventilation, so there was a lot of effort to do proper mechanical ventilation, and we looked at new strategies to have different units so that they wouldn't be running all the time. And so we're trying to increase all the ventilation, make the building much more comfortable, but at the same time saving all the energy compared to the old building.
So there's 3 main parts to the system. There are PVT panels on the roof. The PVT panel produces PV, about 450 watts per panel. It also produces brine, which is fed into a ground source heat pump. People think of ground source heat pumps as being boreholes and ground loops. However, it's more about a water-to-water technology. The water-to-water here being created by the PV and then fed into the ground source heat pump. There is also an air source heat pump as a backup to the system, which creates the first hybrid PVT system in the UK.
For this project, collaboration is really at the heart of the project being successful. We're working to really tight timescales, budgetary constraints, and also utilising systems and processes that have never been deployed before.
Collaboration was really needed constantly in any kind of challenges or complexities that we faced. But if we exposed a part of the existing building that we didn't know how that was particularly constructed, or it wasn't quite constructed as the plans had shown, it was about coming together and finding the best solution for that, and in the shortest space of time possible. So mobilising everybody's collective brain effort to get to the right solution as soon as.
I think this doesn't work without collaboration. We relied so much on information from both BEST but also other consultants.
The overall vision was for us to deliver a project that had added value to the whole built environment ecosystem in Scotland. It showed a roadmap for other public sector bodies on how you can decarbonise your estate, utilising different innovative technologies in order to do that, marrying different pieces of technology with different approaches, and obviously going for a kind of higher energy efficiency standard. So what we were looking for was a project that could deliver beyond the carbon savings directly resulting from the investment made in this building. So we see it as a teaching tool for people to come, share knowledge, to learn from, and maybe get inspired to make other investments in their own estate.
It can seem quite daunting to take on a retrofit project, but particularly for non-domestic buildings, because of the scale of those kinds of buildings, the complexity of it, the various services that are required. And I think that what we've done here at Best is show that this doesn't have to all happen all at once. A phased approach, I think, has really been beneficial.
The industry, unfortunately, struggles with taking risks on new products. It struggles with bringing innovation into the builds, because unfortunately the industry is also very risk averse, and you can understand why it's risk averse. We have fire compartmentation issues across the industry now as a result of the Grenfell tragedy. We have standards being increased across that, and innovation unfortunately often stumbles at that block because people don't want to take a risk on new innovative products. So in having this type of experience with ecosystems alongside John Gilbert Architects and Best, and the processes that we've followed to take the risks calculated and understand that the product can achieve the standards that we want it to achieve across all of those factors, is something that we'll take away from this, and that we'll hope that we can work with our other customers to do similar things.
It is really about what's possible. I think that's the joy of Best. It's taken various technologies and meshing them together to say, yes, this is possible, or indeed, no, it's not possible. And if it is possible, this is the best way of doing it. And this is what we learn from our experience, and that can then be transported across into other retrofits and other projects, which is really important. I think that's the fear factor is what puts a lot of folk off when you start to look at retrofit. They're so used to being in a little box of, I've done gas boilers for years and years now, and that was wherever we went. It was the easiest fix, be it even commercially or indeed domestically. They put these little boxes on the walls that delivered heating and hot water into the house. And then we started to realise that actually we were damaging the environment, and the carbon footprint of them was horrific. And now we're trying to change people's perspectives and minds about that situation, which is very difficult to do. But every system that goes in makes that change, and that's really important.
So what are the future plans for Scotland's National Retrofit Centre? We're hoping not to stop here. We hope that future phases will take the Retrofit Centre to full EnerPHit certification and deliver more improvements across the Best campus. Today, the Retrofit Centre is the headquarters for Retrofit Scotland. It's a place to upskill, to demonstrate, to innovate and to collaborate. The work is only beginning, but together we're building Scotland's net zero future.